adesso abbiamo un contributo registrato della dottoressa Penelope Hogarth. Il titolo è Strategie terapeutiche per bypassare i difetti metabolici associati a PKAN, i risultati dello studio clinico CoA-Z. Quindi non ci saranno domande, ma ascolteremo solo la relazione. Grazie.
Hello, greetings from Oregon. My name is Penny Hogarth. I am a neurologist and I'm the lead investigator on the North American CoA-Z trial. For more than 20 years, I've been part of a wonderful team at the Oregon Health and Science University that includes Susan Hayflick, Alison Gregory, Sue Young-Jung, and maybe others that you know there. Thank you for the invitation to present some results from the CoA-Z study. This is the metabolic pathway that doesn't work properly in PKAN. CoA-Z is actually a compound that sits in the middle of this pathway. Its full name is 4-phosphopantothene. Now, I'll admit this diagram is rather daunting to look at unless you're a biochemist, and so I'm going to simplify it in order to explain why we think that CoA-Z may help PKAN. For most people, vitamin B5 in the diet enters this pathway in the cells of the body, and it's transformed in a series of steps into coenzyme A, an essential compound. In people with PKAN, they have a genetic misspelling that blocks this process and is presumed to interfere with coenzyme A production in the brain. And I say presumed because no one has actually been able to prove that coenzyme A is low in the brain or other tissues in people with PKAN. Even though we can't measure coenzyme A, we have developed a way of measuring these two upstream compounds, and we find that they are low in PKAN. As such, together they provide a kind of blood marker or a biomarker. So the CoA-Z trial arose from a simple idea. Could we provide a compound that was downstream of the metabolic block in PKAN and thus fix the broken pathway using the biomarker as evidence that the remedy was working? So before we moved into people with PKAN, the idea was researched over many years, first by Odi Sabone in the Netherlands in PKAN flies, and then in PKAN mice and in cultured cells from people with PKAN by Susan Hayflick and Sue Young-Jung here in Oregon. This important work, the collective work of all of this group, was published in the prestigious science journal Embo Molecular Medicine in 2019, and I've provided the reference there if anybody wants to take a look. We received a number of small grants from local organizations to move this work forward in the lab, and also from the NBIA Disorders Association, in anticipation of needing much larger funding, both to synthesize the compound in larger amounts and also to conduct a clinical trial. We started sister foundations, the Spoonbill Foundation in the US and Lepelaar Stichting in the Netherlands. Many people donated money to these foundations, all the way from children raising money from lemonade stands, as you can see in this one lovely picture, and then a whole community building a house with donated labor and materials, selling the house and contributing the funds to the Spoonbill Foundation. We also sought large grants from the federal government here in the US, and I was ultimately awarded a grant from the National Institute of Child Health and Human Development at NIH in 2019. I was fortunate enough. So first of all, we did a small so-called proof of concept study in just 3 adults and 3 children with PKAN. These were brave folks, brave families who were willing to be the very first people to take our synthesized CoA-Z. It was just 14-day treatment period, and then 14 days of follow-up with biomarker draws and safety labs being drawn at intervals throughout. We were relieved that nobody had any adverse effects during the 14 days of treatment, and we were very happy to see that CoA-Z raised the biomarker in all 6 participants. This gave us some confidence to move on to a much larger clinical trial involving adults and children with PKAN from the US and Canada. So what questions did we want to answer? Well, the main goals of this trial were to see whether CoA-Z was safe, i.e. did it cause any adverse effects or abnormal labs? Was it well tolerated, meaning if there were adverse effects, did they stop people from taking CoA-Z or did they drop out of the study? Or were there any problems with following the dosing regimen or otherwise sticking to the requirements of the study? And perhaps most importantly, we wanted to see if CoA-Z reliably changed the blood biomarker. Now, importantly, based on its mechanism, we do not really expect CoA-Z to improve the symptoms of PKAN. This study was not designed to detect this. Rather, our hope is that CoA-Z may slow progression of PKAN, especially if it started early enough in the disease. But this is something that will take much longer to prove than we were able to do in this study. We took an unconventional approach to the study conduct. Instead of participants traveling to Oregon for study visits, they were conducted by phone, and blood draws were done in the home community using mailed kits. We justified this approach because the compound, as a vitamin B5 metabolite, was predicted to be very non-toxic. And we also did it to reduce the risks and burden of long-distance travel for families, especially here in the US. The distances are so long, so far, and as many of you know, the stress of travel can cause dystonic crises or other difficulties. The study was designed this way before anybody had even heard of COVID. More about that in a minute. The study consisted of a 6-month double-blind phase in which participants were assigned to either low, medium, high-dose CoA-Z or to placebo. We planned for 50 participants, about 50, divided equally between these 4 groups, with the goal of having 12 people in each group be able to complete 6 months. So we allowed for a couple of dropouts. Then the plan was for all participants to transition to an open label phase on the medium dose. We opened enrollment in December of 2019. Just think for a minute where we were in terms of COVID in 2019. We were nowhere. We'd never heard of COVID. So the blue line in this graph shows the pace that we expected to enroll our 50 participants. The orange line shows the actual pace, which, as you can appreciate, was much, much faster. In December of 2019, we had no idea that the whole world would shut down just 3 months later. However, our remote design, unconventional though it meant that our study wasn't really impacted at all by the pandemic, even as other clinical trials were scrambling to transition to remote conduct. And in fact, we had so many people with PKAN wanting to enter the trial that we decided to expand the study to more people and to follow them for longer in the open label phase. So as the pandemic created chaos and heartbreak all around us, we were taking delight in our smoothly running trial. We were feeling rather smug. However, our trial was eventually disrupted by an unprecedented ice storm in Texas, which combined with some pandemic-related supply chain issues led to delays in the synthesis of CoA-Z. With input from our Data Safety and Monitoring Board and the National Institutes of Health Advisor, we decided to close the open label phase earlier than planned. But all of the participants who were in the expanded cohort completed the important double-blind phase. And many of these folks also completed 18 months of the open label phase. So we'd asked these questions, and we found that CoA-Z was indeed safe, it was well tolerated, and perhaps most importantly, we found that it not only changed the levels of the biomarker, but it did so in a pattern just as we had expected. We predicted before the study started that we would see levels first rise, with the higher doses rising faster, and then fall as CoA-Z replenished and fixed the broken vitamin pathway. And indeed, that's exactly what we see here. This is what's called a very nice dose response. So we see exactly what we predicted, high dose rising faster, then dropping down, medium dose rising slower, low dose rising slowest of all. So what's next? So we can now share with the PKAN community. We've been a little quiet about this all the way through this because we weren't sure whether we would be able to pursue this pathway, but we can now share with the PKAN community that we're in fact not planning to develop CoA-Z as a drug, but rather as a medical food in the US, and this is called a food for special medical purposes in the European Union. This is a special category of medical products. It goes through a very different and generally faster and less costly regulatory pathway than drugs. It also, just as an aside, it is a part of the reason why we limited the study goals as we did. I should tell you that the Food and Drug Administration in the US has been aware of our plans to develop CoA-Z as a medical food for several years. The agency has been very supportive and helpful to us. And we're currently in the midst of preparing to present the CoA-Z data in a big formal meeting to the FDA in the coming months. If the agency approves our application, we anticipate the regulatory process in the EU will follow, led by our colleagues in the Netherlands and in the UK, where other trials have either been completed in the Netherlands or they'll soon begin in the United Kingdom. We'll post updates on our nbiacure.org website, so you can follow along to see what's happening on that front. With that, I'd like to just acknowledge my team, our generous funding agencies. This is us on Rare Disease Day. And finally, I'd like to just thank you again for inviting me.